Okay, now we're going to look at our second important fact, and that is different compounding periods. You'll notice I've put compounding in inverted commas because this only refers to when we're working with compound interest. Okay, let's have a look how this impacts our examples. So we've got our compound interest formula, and we remember that 12% per annum, because it's 12% is 12 over 100, which is 0.12 per annum is per year. Now what happens if we take this 12% per annum and it's compounded annually? In other words, the interest is charged right at the end of the year, or end of a financial year, but end of full 12 months. That would mean we would take the 12% and we would only charge it at the end of the year, and that would be 12%, 12 over 100, which is 0.12. Now, what if the interest rate is 12% per annum, in other words, 12% for the full year, but it's compounded monthly? In other words, that 12% is worked out monthly at the end of every single month. Now, that means because it's per annum, that 12%, that means that that 12% has to be split over the 12 months, which essentially means we're going to be charging 1% there, 1% there, 1% there, because it's 12% per annum and it's charged monthly. So essentially then what we would do is 12% per annum, which is 0.12, is divided between 12 equal, because it's 1 per month, that 12% is divided by 12 because there are 12 months in a year. So it would be 0.112, which is 12%, but divided by 12. Happy with that? Hope so. What happens if it's 12% per annum compounded quarterly? In other words, I'm charging interest every quarter of the year. Now, every quarter of the year is going to be, let's see, 12 months divided by 4 is every 3 months. So in other words, after 3 months, I'm going to charge interest there. After another 3 months, I'm going to charge interest there. After another 3 months, there, and another 3 months there. So in other words, at 4 times within the year, I'm going to be charging interest. So that 12% is going to be divided by 4 because it's going to be charged at 4 times within the 1 year per annum. So that's going to be 12%, which is 0.12 over 4, because at 4, every quarter, I'm charging the interest of 12% per annum. What happens if it's 12% per annum compounded biannually or semi-annually? Those are the words they use. That means every half year, twice a year, I'm charging interest. So that's 12 months in a year, and I'm charging it twice. That would mean I'm going to charge it 1, 2, 3, 4, 5, 6 over here. Okay, I'm charging interest there, and I'm charging interest at the end of 12 months. I'm charging it after 6 months and again after 12 months. In other words, that 12% per annum is divided by 2 because I'm charging twice. So 12%, which is 0.12, divided by 2. Okay, so that's essentially how I would change. We've looked at I. Now, if I changes, surely that means the number of time periods is also going to change. Because in this example here, I only charge interest once. 0.12 was charged once at the end of the year. So n would be equal to 1. But what if I charge interest every single month? Then every single time period is no longer 1. N now would become 12, because at 12 different times I'm charging interest. Okay? If it's quarterly, the N is now no longer 1 because I'm not doing it once, no longer 12 because I'm not doing it 12 times. N would be correct, 4. What if I'm doing it twice here? What would N be? 2. 1, 2. So essentially, when we change the compounding periods, your I changes and so does your N. And I'm going to look at an example now with you on the whiteboard, how this affects the working, whether it's charged, compounded monthly, quarterly, biannually, etc. Also keep in mind is, what if it is compounded daily? That means that each of every single day the interest is being charged. So then we would take, what do you think? We would take our 12% interest, which is 0.12. How many days in a year? If it's not a leap year, 365. So that would be my interest charge per time period. And what would N become? How many times would I charge it? I would charge it 365 times because I'm charging it on a daily basis. And that in a way is the most accurate, isn't it? Because if you want to draw your money on any particular day, the interest would need to be charged up until that day. Anyway, let's move on to a practical example now. Okay, now we're going to move on to this practical example. So I have 10,000 Rand is invested at 12% per annum for 5 years, compounded monthly. So in each case, I've used my compound interest formula, and in each case, my P or my original amount is 10,000. What's changing is the fact that it's compounded monthly, quarterly, annually, or biannually. So let's quickly have a look how this affects, firstly, the interest rate, and secondly, N. So if my 10,000 Rand is invested at 12% per annum for 5 years, compounded monthly. Now remember, if it's compounded monthly, that means at the end of every single month, interest is charged. So my interest is 12% per annum, which remember is 0.12. But if that 0.12 is charged every month, it's going to be 0.12 divided by 12 because it's per annum. Now, how many time periods is that in 5 years? So if you think about it, we've got 1, 2, 3, 4, 5 years. And every single year, I'm charging interest 12 times. That would be 12 times there, 12 times there. So it's going to be 5 times 12. So my N was 5, but it's times 12, which is 60. Let's have a look at the next one. Then you get your answer on your calculator. Okay. Then if we look, if it's charged quarterly, my 10,000, then it's going to be still 12% per annum. Oopsie, 0.12. But if it's charged quarterly, that's 4 times a year, so it's divided by 4. 5 years, but it's charged 4 times every year, so that's 5 times 4, which is 20. Let's replace that with 20. Okay, so you know how we got it. What if it's charged annually? That means just at the end of every single year. So that would be just our normal formula. It would be 12% per year, which is 0.12. For 5 years, at the end of each year, N is 5. Or 5 times 1. Let's leave this with 5 times 4, because I want to point out something. Then if it's compounded biannually, that is twice a year. So that would be my 12% per annum, split over twice, 2 times a year. So that's going to be divided by 2. It's for 5 years, but it's twice every year. So it's 5 times 2, which is 10. Now you'll notice it's worth remembering that whenever our compounding period is changed, 2 things change: interest and number of time periods. So that changes and that changes. So that is divided by 12 times by 12, divided by 4 times by 4, divided by 1 times by 1, divided by 2 times by 2. So it's important just to see that consistent, to remember that both of them change. Now let's quickly work out the answers. And I'm assuming that you are very competent on your calculator. I'm going to just work out 2 very quickly. So this is going to take time. Maybe you can do it quickly as well. So then that's 1 plus to the power 60. And we get 181,18166, comma. Now let's round it off. Because we're dealing with rands and cents, it has to be to 2 decimal places. So it's going to be 97. Just some comments there. Often your paper will be round off to 1 decimal place, but whenever we're dealing with finance, it is always 2 decimal places because it's rands and cents. Okay, and cents is out of 100, so it's 2 decimal places. Quarterly, let's quickly do that. So it's 10,000, open brackets, 18061. I hope you're doing this the same time as me, Make sure that you now understand the theory, but you also are competent at using your calculator. The reason why I'm taking time to do this is because I want to compare the answers. 4, 7, so that goes 4, 8. Okay, hopefully I've worked out correctly on my calculator. Now let's compare these values, okay? The biggest amount that I'm going to have at the end of 5 years is going to be this one here. And that really is no surprises because I've compounded monthly here. In other words, the number of time periods was the most. In other words, I was working out the interest on the interest the most time. So it would make sense to grow the most. You might say to me, well, that's like 100 rands different. Well, how much is 100 rand really? Well, 100 rand is a lot of money. And when you're dealing with possibly not 10,000, but 100,000 or a million or whatever in your investments and your banks and your lenders, etc., that amount grows to thousands and hundreds and possibly even millions of rand. So it does make a difference how often it's compounded. Okay, I'm going to leave it for there, and now we can try some on your own. Thank you. Okay, now we're going to look at some examples where there are different compounding periods. So Sia invests 10,000 Rand at 15% compound interest. Now remember, we like to highlight this. How much will Sia's investment be worth in 4 years' time? Okay, so what we're essentially looking at, if he invests that, that's going to be his P. Compound interest, this is going to be his I. And in 4 years' time, this is going to be his N. So if we stick it into our compound formula, we work it out in the calculator, we get 17,490 Rand and 6 cents. But now, what if he invests it and it is compounded monthly? Remember, the N is going to change, and so is the I. Both of those are going to change. So now, once again, our investment is still 10,000. The interest rate is 0.15, but if it's compounded monthly, it's got to be split up per annum over the 12 months, so it's divided by 12. And if it's still for 4 years, remember, it's 4 years times 12 times each year, which gives us 48. And if we work that on a calculator, it comes to 18,153.55. Remember, you can press pause in the video if you're wanting to work this out slowly, and I would advise that. Okay, so then what happens if it's worked out semi-annually? So we still invest the 10,000 Rand. This time, the 15%, which is 0.15, is compounded semi-annually, which is twice a year. So twice a year, so that 15% has to be split over 1 year twice, so that's divided by 2, and then it's still over 4 years, but twice every year for 4 years, which means it's to the power 8. N is now 8. Okay, work that out on the calculator, we get 17,834 Rand and 78 cents. What happens in the fourth case if it's compounded quarterly? My initial investment is still the same. Now that 15% per annum is charged every quarter, 4 times a year. So it's got to be split 4 ways, divided by 4. It's still for 4 years, but if it's 4 years at 4 times every year, my N is now going to become 16. And that becomes 18,022 Rand and 28 cents. Now what I would like to do is just quickly once again compare these values. Which one is the biggest? That one, that one, that one, or that one? It looks like this one here is the biggest. So once again, we get the biggest returns for our money, for our investment, if we have the monthly, compounded monthly, which makes sense again. It's compounded more frequently, so it grows quicker. Okay, let's move on to one more example. We start again with highlighting what we need to highlight. At what interest rate, compounded quarterly, must 32,000 be invested in order to grow to 50,000 in 5 years' time? Now, don't be scared to read this a few times. It's like a word problem, so we have to read it a few times. So we read it again. At what interest rate, compounded quarterly? Okay, so we remember that means I've got to divide by 4, my interest rate. Must 32,000 be invested? So that's going to be my P in order to grow to that. So I'm going to end up with that. So that's my accumulated amount. And this is going to be 5 years. So that's going to be my N. But my N is going to be affected, remember, because it's compounded quarterly, not annually. So we start off with our compound interest formula and we just plug in the values. Starts off at 32,000, grows to an accumulated amount of 50,000. Now the interest is going to change. Okay. So let's see. That's the question. We want to know what is the interest rate. But if it's compounded quarterly, I want to divide by 4. And remember, your 5 years is how long this is going to be invested. But if it's compounded quarterly, that's 4 times a year. So it's 4 times a year for 5 years. It becomes 20. Okay, so your N is 20. And now we want to solve for I, which is sitting over there. So we need to slowly, bit by bit, undo it. So remember, the first step is you always divide by the 32,000. That's what it looks like. Then we want to get rid of the 20 next. So that would mean we take the 20th root. All I've done is cancel these zeros here. Then the next step is to subtract the 1. And the final step, once I've subtracted the 1, is to times by the 4. And we end up with an I value of that. Now remember, that's not yet as a percentage, written as a percentage. So that's your I value. That would be 0,09026 blah, blah, blah. But if we want to write it back as a percentage, it's going to be times 100. So that would leave us with 9.03%. Remember, how do you get back there? It's going to be 9.03 over 100. Which will give us 0.0, that one there. Okay. Trust that you are fine with that. And now you can go and practice a few more on your own, having some worked examples here. It might also be useful to work through these examples again. Thank you.